In this video, we'll review the differences and similarities between expressions, equations, and formula, and then we'll look at solving equations with one variable. We'll also look at writing algebraic equations or formulas in order to show how we'll solve a question. Just to recap, in a previous video, we talked about how an expression is the algebra without an equal sign, for example, 4x plus 5. This shows how you would calculate something with reference to BIDMAS without actually doing so. An equation has an equal sign, and if it has one variable, that means it could be solved. For instance, 4x plus 5 equals 21. Formulas are equations that are set to solve a real-life problem, and the variables represent numbers that can be taken from the problem or prior knowledge, as we'll see. An example for this would be the formula for the perimeter of a rectangle, which is P equals 2 times L plus W in brackets. As you may remember from the previous videos on rearranging equations, we've got two processes that we can use, and we can continue to use these when solving equations with only one variable. Both of these processes are based on the knowledge of BIDMAS, but use that knowledge in different directions. Here we have the equation b take away 7 equals 12. So if to use the function method, we'd look at b, which is what we're trying to solve. The first thing we would do with that is we would take away 7, and that would equal 12. If we look at reversing that, we would have 12, and then we would do the opposite of what's on top, which is to add 7, and that would give us b. So we can now say b, if we work from right to left, 12 plus 7 will equal 19. Now using the balance method, we've got b, take away 7 equals 12. To undo the take away 7, we're going to add 7 to that side, and because it's a balance, we want to add 7 to the other side as well. And we end up with b equals 19. In this problem, we have the equation 4x plus 3 equals 19. Now this has more than one operation going on in it, so it will take us a couple of steps to work through it. We'll look at the function method first. So x is what we're trying to solve. So what would we do with x first? Well, we'll do times by 4, and then we'll add 3 to make 19. If we reverse that and do the opposite to 19, we'd have 19, and we'll do the opposite of what's above, which is take away 3. Then we'll divide by 4, and that would give us x. So we can say that x equals 19, take away 3 is 16, divided by 4 is 4. If we look at the balance method, we're going to undo the plus 3 first, because we're going to look at doing BIDMAS in reverse. So instead of adding 3, we're going to subtract 3. Don't forget, it's a balance. We need to do it to both sides. So we're going to subtract 3 from both sides, and we'll end up with 4x equals 16. And then to undo the times by 4, we're going to divide by 4 to both sides, and we end up with x equals 4 as well. Again, we have another equation which will take 2 steps to solve. We'll look at the function method first. So t is what we're trying to solve. So we'll do t, and we're going to times it by 2, and then we would add 8 to equal 3. If we were to reverse that, we would do 3, and then we'll do the opposite of what's above, which is take away 8, and then we'll divide by 2, because that's the opposite of what's above. And that would equal t. Now, in this case, 3 take away 8 is going to give us negative 5. And divided by 2 can either be shown as negative 5 over 2 or negative 2.5. And we'll see that easier in the balance method. So with the balance method, we'll take away 8 from both sides. Remember, we need to keep it balanced. We'll end up with 2t equals negative 5. We'll then divide both sides by 2. So here we end up with t equals negative 5 over 2, or negative 2.5. It can be left as the improper fraction or as a decimal, but in both cases it's negative. In this problem, we have divisions in the equation, so we'll look at how we deal with these. We consider that everything that's on the top of the fraction is being divided by the denominator. So it's easiest in this situation to consider that everything that is a numerator as being in brackets. Again, we'll use the function method first. So if we think of the y minus 4 as being in brackets, we'll put those in. We'll do y, take away 4, because we do what's in brackets first, and then divide by 3, and that would equal 2. If we were to reverse that, we do 2, and then we'll do the opposite of what's above, so we'll times it by 3, and then we'll add 4. And that would equal y. So we can say that y equals 2 times 3, which equals 6, plus 4, which would give us 10. So here with the balanced method, again, we're going to consider what's on the top of the fraction, the numerator, as being in brackets. So we'll put those brackets around the y, take away 4. To undo the divide by 3, we're going to times by 3 on both sides. That'll leave us with y, take away 4 on the left, and 2 times 3, which would be 6 on the right. Now we're going to add 4 to both sides, which would give us y equals 10. In this question, we've got more than 2 steps to solve this problem, but it can be quite simple if we stick to using BIDMAS. This now starts to show the limitations of using the function method, so do try and move to the balanced method for solving further equations. You should find if you've been looking at both methods, there's a lot that both the processes share. So to look at the function method first, if we were to take x, which is what we're trying to solve, first we would times it by 3, we would then add 5, and then divide it by 2 to get 7. So if we reverse that, we'd have 7 times by 2, because it's the opposite of what's above, subtract 5, and then divide by 3 would equal x. So 7 times 2 would give us 14, take away 5 would give us 9, divide by 3 would give us 3. And we can say that x equals 3. And you can see how much quicker that is using the balance method. We'll consider the top as being in brackets, so we'll do that last. So the first thing we want to undo is the divide by 2. By timesing both sides by 2, we get 3x plus 5 equals 14. 7 times 2 is 14. Now we're going to subtract 5 from both sides. So we end up with 3x on the left-hand side, and 14, take away 5, equals 9 on the right-hand side. Lastly, we divide both sides by 3, and again, we get the answer of x equals 3. You can see how much quicker this method is, and this is the one that we'll be using throughout the rest of this video. In this problem, we still only have the one variable, x, but it's represented twice, once on each side of the equal sign. We need to look at gathering these like terms first before we can look at solving this equation. With these types of questions, with more than one representation of the variable, always aim to collect it on the side with the highest number of the variable. This often saves you having to deal with negative numbers, which can confuse the situation. So what we're going to do is, on both sides, we're going to subtract 3x. Therefore, we'd end up with, on the left-hand side, 5x take away 3x would give us 2x. On the right-hand side, we can get rid of the 3x by subtracting the 3x, and we just end up with 16. Now, to get rid of the 2 times x, we're going to divide by 2, so that would leave us with x on the left, and 16 divided by 2 would give us 8. So in this problem, x equals 8. In the next problem, we have several steps again, one of which includes a power. Be sure to pay close attention to how we display the answer to this problem. So we have 2x squared plus 4 equals 166. The first thing we'll do is undo the plus 4 on both sides by subtracting 4 on both sides. That'll leave us with, on the left-hand side, 2x squared, and on the right-hand side, it'll equal 162. Now we're going to undo the multiplication, because we have 2 times x squared, by dividing by 2. And we're going to do that to both sides. So on the left-hand side, we have 2x squared divided by 2, which just gives us x squared. And on the right-hand side, we have 162 divided by 2, which gives us 81. Now, as you've seen in previous videos, we've talked about the opposite of squaring something is to square root it. So we're going to square root both sides. The square root of x squared is just x. The square root of 81 is going to be 9, but the answer can be either positive 9, because positive 9 times positive 9 gives 81, or negative 9. So it could be negative 9 times negative 9 gives us 81. So we write this as x equals plus or minus 9. Either of those could be our answer. This time we'll look at how to deal with roots in an equation when we're attempting to solve it. Here we've got 9, take away the square root of x all over 4, which equals 1. So the first thing we're going to look at, again, we're going to consider the top of this fraction as being in brackets. We're going to times both sides by 4, which would give us 9 minus the square root of x equals 1 times 4, which gives us 4. We're then going to subtract 9 from both sides. So we've got negative the square root of x equals, and then 4 take away 9, it gives us negative 5. Now we have both sides here as being negative. So a trick that we can use to avoid having negative numbers is by timesing both sides by negative 1. If we do that, we end up with the square root of x on the left and positive 5 on the right. Now, the opposite of a square root is the power of 2. So the square root of x times the square root of x will give us x, and 5 to the power of 2, or 5 times 5, would give us 25. So the answer to this question is x equals 25. In this next question, we have an x on both sides, and we'll be using expanding the brackets to solve it. A later video in this series shows you how to factorise and expand in algebra, but we'll use it here to solve this equation. Remember, look for the highest value of the variable, and that will be the side that it ends up on. So here, we're going to times both sides by 3, because we've got to remember everything on top of the fraction is in brackets. So we end up with 2x plus 1 on the left-hand side, and on the right-hand side, we put it into brackets, and we put a 3 on the outside to say that we're going to multiply the whole thing by 3. Next, we'll do what's called expanding the brackets. So we'll do 3 times x to give us 3x, and 3 times negative 2 to give us negative 6. On the left-hand side, we still have 2x plus 1. Now I want to get all the x's together. The 3x on the right is higher than the 2x on the left, so I'm going to move all of the x's onto the right-hand side by subtracting 2x from both sides. So that gets rid of it on the left-hand side, and I just have 1. On the right-hand side, I have 3x, take away 2x, minus 6, which gives us x minus 6. Now I want to get rid of the negative 6 by adding 6 to both sides. So I have on the right-hand side x, and on the left-hand side 1 plus 6, which gives us 7. We could always turn this round to say x equals 7. And that's the answer to this problem. In this equation, we have an x as part of the denominator. So we'll use our understanding of fractions to get rid of that denominator, and again, we'll be using expanding brackets to solve this problem. What we're going to do is we're going to put the denominator into brackets, and we'll multiply both sides by that denominator. So by timesing the left-hand side by x minus 3, we can actually cancel that denominator out, and we just end up with x plus 7. By timesing the other side by x minus 3, we end up with negative 4, brackets, x minus 3, close brackets. The next thing we want to do is expand those brackets. So on the left-hand side, we still have x plus 7, and on the right-hand side, we have negative 4x, because negative 4 times x. Negative 4 times negative 3 will give us plus 12. So on the right-hand side, we have negative 4x plus 12. Now we can see more clearly where we can end up putting our x's. We're looking for the side with the most x's. Now here, the trick is to recognise it as a negative 4x. That's lower than 1 positive x. So we're going to add 4x to both sides. When we do that to the right-hand side, negative 4x plus 4x leaves us just with the 12. On the left-hand side, we have x plus 4x, which gives us 5x plus 7. So now we have 5x plus 7 equals 12. We're starting to see the answer come more clearly now. We're going to subtract 7 from both sides to get 5x on the left-hand side and 5 on the right-hand side, because 12 take away 7 gives us 5. Divide both sides by 5 will give us x equals 1. So that's our answer for this problem, x equals 1. In this next question, we're asked to form an expression. We know that the perimeter of the shape is the sum of all the sides around that shape. So what we can do is we can combine all of these terms together. We have 5x minus 2 plus 3x from the right-hand side and 3x from the left-hand side, and finally we can also add on the 4x plus 8 underneath. We can gather all these like terms together, so 5x plus 3x plus 3x plus 4x would give us 15x in total. We can then combine the numerical ones of 8 plus negative 2, which would give us 6. We're then told that perimeter equals 156 centimetres, and we can change this from an expression to an equation because we now know what this equals. So we can write 15x plus 6 equals 156. Again, we want to get x on its own, so we'll look at doing BIDMAS in reverse. So the first thing we'll do is take away 6 from both sides. That'll leave us with 15x on the left-hand side, and then 156 take away 6 would give us 150 on the right. Now we're going to undo the multiplication by dividing by 15 on both sides. So 15x divided by 15 would give us x, and 150 divided by 15 would give us 10. So that's going to be the answer in this problem. We've solved for x, which equals 10. So in this next question, we'll be using some knowledge of triangles to form and solve the equation. We'll be covering the angles of a triangle in a future video, but for the moment, just know that the angles in a triangle equals 180 degrees. The notation on this triangle shows that it's an isosceles triangle, and therefore the base angles will be equal. Because the base angles are both equal, they're both going to be x, which means both those values will be the same. Here, we're going to solve for the angle of x. If we know that the angles in a triangle equal 180, we can do 180 take away 42, because that's the other angle in this triangle. That gives us 138. Because we know that both of the bottom angles are the same, there's 2x, so we can divide it by 2 and get 69. So we now know that x equals 69. So that's the answer for this problem. In this video, we looked into the differences between an expression and an equation, and how to solve equations with a single variable. In the next video, we'll look at factorizing and expanding algebraic expressions. And I'll see you then.